We're going to work out some standard deviations now. The calculator I'm doing this on is an emulator for the Casio ClassPad 400. It's very similar to the Casio ClassPad 300. You shouldn't have any trouble there. If you're using another brand of calculator, then you may wish to consult your calculator companion to work out how to do standard deviations. Okay, this first one here, it's actually not the trout data, I think it's the taxi data you'll find. The taxi fare data, and we're going to work out the standard deviation. So the first thing we'll do is have to enter this as raw data into our calculator. So the first one, 06 means $6, 08 is $8, $12, $14 and so on. So we're going to go into statistics mode, and we're going to enter all of this data in here. So 6, 8, 12, 14. I'll let you enter it yourself. I'm just going to pause for a second and do that. You should find that once you've got all the data finished, you've got 24 pieces of data in there. And so what we're going to do is calculate. Now this is one variable statistics. All the stuff that you do in this course will be one variable statistics. And we've got one variable, the X list is list 1, and the frequency is 1. We've entered all of these pieces of data individually, and so that means the frequency is 1. When you've got that, you need to press OK, and what you'll get is a huge big long list called a statistics summary, and part of that will be the mean. You'll have the median, they'll have the quartiles and bits and pieces, but we are particularly interested in the standard deviation, and you'll find the standard deviation there is this one here, sigma x, 13.03. Standard deviation equals 13.03. We're going to move now and do some data which is presented as a frequency table. So with this next one, let's just close that and clear everything, and we're going to enter the contents into list 1 and the frequencies into list 2. Just pause the calculator while I do that. Okay, I seem to have the data in there okay. So what I want to do is calculate one variable statistics again. Now this time, the important thing is this. I've got my X list, my scores in list 1, but the frequency of those, the number of times each score occurs, is in list 2. So with frequency data, you need to set up a list for your frequencies. So with frequency data, list 1 and list 2, and you'll get the statistics summary, part of which, can you see there, is a standard deviation. The standard deviation is equal to 3.217. It's good practice to use a few decimal points with a standard deviation. And now we're going to do the last one, so we'll clear our lists and we'll enter them. Now when we do this one, what we've got is some data which has been done in groups. So we've got here different speeds, and this first group is a group for all cars that we're doing between 40 and up to 50 kilometres an hour. The next group is 50 and up to 60 kilometres an hour. Now when we do this, we need to put in our first column, we're going to put the midpoints of each one. So we really need an extra column on here. Not really enough space for it. I'm going to tack it onto this side. So my X values are the midpoint of each group. So the midpoint from 40 to 50 is 45. What we're assuming is that these two cars were both doing the speed of the middle of this group. They were both going 45. These 5 cars were both going the middle of this group, 55 kilometres an hour. Now when I enter the data, this is my X list and this is the frequencies. So I'm going to enter in the data. The first piece of data is 45. And 55, then I'll enter the appropriate frequencies here. I'll just pause and do that. Okay, that's done. So we're going to calculate one variable statistics. Our X list is in list 1, but the frequencies for each of those I've put into list 2. So press OK, and it all does everything for me. A statistics summary includes everything, including a standard deviation. The standard deviation of this group of scores is 11.37. Symbol for standard deviation. 372, I'll say. Okay, just a couple of another little question to finish there. It says, which of the following histograms shows the largest standard deviation and which would have the smallest? Now, standard deviation is a measure of the spread of data. Is the data all very similar to each other, or is it spread far and wide? Now, I would say this one here, the data is all very clustered around the mean. That means all the data, or a lot of the data, is very similar. This would have the smallest standard deviation. Because the data is clustered, it's got a small spread. This one here, the data is spread very wide. There's a lot of data that's a long way away from the middle value. So for this one, this would have the largest standard deviation. It's got a large spread.